In this lesson, we're going to cover ratio, rate, and proportion. We'll first discover what ratio is. Ratio is about comparing two things, and they belong to the same type of things. In the first example, we have apples and oranges. So these are fruits. We have squares and triangles, and these are shapes. Pizza and hot dogs, these are foods. When we compare things, we also compare their numbers. In the first example, we have 5 apples and 3 oranges, and we write ratio in this fashion. You write a 5, a colon or 2 dots, and a 3. We say this 5 to 3. Next example, 6 squares and 3 triangles. We write a 6, 2 dots, and a 3. And we say this is 6 to 3. Next one, 8 pizzas to 4 hot dogs. And we say this is 8 to 4. In ratio, we like to reduce the numbers to the lowest possible, to the lowest whole numbers. In the first example, we have 5 apples and 3 oranges. 5 to 3 is the lowest. We cannot reduce it any more because we cannot find a number to divide the same on both sides. 9 squares and 3 triangles, we can reduce it. We can reduce it by dividing 3 on both sides. So if we divide 9 by 3, you get 3. And you divide 3 by 3, you get 1. Let's try the next example. We know 8 to 4 can be reduced because we can divide both sides by the same number, number 4. 8 divided by 4, you get 2. And 4 divided by 4, you get 1. Let's try some examples. There are 12 boys and 8 girls in the classroom. So we write it 12, 2 dots, and an 8. Now we know the numbers in this ratio can be reduced. We know that they both can be divided by 2. So you get 6 to 4. And we also know this number can be reduced even further. If we divide by 2, you get 3 to 2. And that's the answer. Now let's try the other one. In the school, there are 40 chairs and 100 desks. So it's the same thing. We would write 40 to 100. Now we have zeros that we can cross off. And now we have 4 to 10. Now we know we can reduce this even further if you divide it by 2. If you divide by 2 on both sides, you get 2 to 5. And so that's the answer. Let's try another example. The lady has 20 dogs and 15 cats. So we would write 20 to 15. Now we do know that they cannot be divided by 2 but we can divide them by 5. So if we divide 5 on both sides, we get 4 to 3, and that's the answer. Now let's go for the other one. Canada has 10 provinces and 3 territories. So 10 to 3. Now here, we cannot reduce it any further because both sides cannot be divided by the same number. So 10 to 3 is the answer. Now we're going to learn about rate. Rate is also a ratio, a type of ratio, but it's a special type of ratio. It's comparing different things. So in the first example, we have dollars and cans. We have $6, so we write it like this. And we put a slash and 12 cans. Now we would say this symbol has per. So it's $6 per 12 cans. Let's do the next one. We have words and minute. So we would say the number here is 30. So we have 30 words per minute. Again, we use the word per. Last one, we have 100 kilometers per 1 hour. So it's 100 kilometers per hour. Rate can be simplified, and we usually want to find per unit. And in the first case, we have $6 per 12 cans. Now we want to find how much per can. In this case, if we divide here by 12, we get 1. So it's per can. If we divide here also by 12, we get 1/2. Now we know 1/2 of a dollar is 50 cents. So it's 50 cents per can. Next example is already simplified. You have per minute, so you don't need to simplify them anymore. And the next one, 100 kilometers per hour, so it's already simplified. Let's try to calculate some rates. In the first question, if Big Tom ate 50 hot dogs in 5 minutes, how many hot dogs did he eat in 1 minute? So we do know that we want to find per minute. So we put 50 at the top, hot dogs, over 5 minutes. Now we can simplify this because we know we can divide 5, top and bottom. If we divide 5 at the top, we get 10, and we get 1. So this is perfect. So we have 10 hot dogs per minute. Right. Let's look at the next question. Farmer John's chicken laid 100 eggs in 10 days. How many eggs did he collect per day? So it's the same thing. We know we want to find per day. So we'll put the eggs at the top, 100 eggs over 10 days. Now we know we can simplify this quite easily by canceling out the zeros because we have top and bottom zeros. And we have 10 over 1. So it's 10 eggs day. Let's calculate more rates. In the first example, Donovan bought 8 whole pizzas for his party. It cost him $96. Now here, it doesn't tell us how to calculate the rates. So let's see which makes more sense. Do we put pizza over dollar or dollar over pizza? Now we know when we buy pizza, we always ask how much per pizza. So this makes more sense. So we put $96 over 8. We know we can divide 8 with a top and bottom number. So we get 12 over 1. So the answer is $12 per pizza. Let's try another example. After 1 year of work, Haley managed to save $12,000. Now, it would make a lot more sense if we put dollar per year. In fact, better still, dollar over 12 months. So we have 12,000 over 12, and we get per month. We can divide 12, top and bottom number. We get 1,000, and we get 1. So the answer is $1,000 per month. Now let's take a look what proportion is. Proportion is when one ratio is equal to another. So if you remember from earlier, we write 5 to 3. 5 apples to 3 oranges. Now, if we were to increase this to 10, which means we double, we also double oranges to 6. So if you look at this ratio, 5 to 3 equals 10 to 6. Let's try some examples. You can either increase or decrease a proportion. So the first example, increase the ratio proportionately. You have 2 to 3, and we want to increase 4 to something. So what you can do is this: 2 over 3 equals 4 over something we don't know. Now, from 2 to 4, you know this is times 2. So you multiply the bottom by 2. 3 times 2, you get 6. So the answer would be 4 to 6. Now you can also decrease the proportion. And here we have 12 to 4. You write it as a fraction. And you have 6. And you want to find out what's at the bottom number. Now you know 12 to 6 is divided by 2. So you do the same thing, divide by 2, and you get 2. So the answer would be 6 to 2. So we have seen how proportion can increase or decrease. This type of proportion is called directly proportional. Let's see another example. To make a basic pie dough, it requires 1 pound of butter for 2 pounds of flour. How much butter is needed if the flour is increased to 4 pounds? So we know that 1 pound is ratio to 2 pounds of flour. How many butter if we would increase the flour to 4 pounds? So we write it has a fraction, and we proportionally increase. We don't know what the top number is yet, and we know it's 4 pounds. So we know 2 times 2 is 4. So we multiply by 2 at the top. So we have 2. So now we know we need 2 pounds of butter, or 2 pounds of butter to 4 pounds of flour. Let's take a look at another example. Speedy Joe takes 6 minutes to drive 10 kilometers. How much time would it take to drive 5 kilometers? Once again, we'll do it in a fraction. And we have 5 at the bottom. We want to find what's the top number. Now, we do know that if he were to reduce the distance from 10 to 5, that is 10 divided by 2. So we do the same. 6 divided by 2, we get 3. So now we know he would take 3 minutes. And the ratio is now 3 to 5. Now we'll take a look at another type of proportion. It's called inversely proportional. This is when you increase one side and the other side decrease, or you decrease one side and the other side increase. Let's take a look at an example. It took 4 boys to each eat 40 chicken wings. How many chicken wings will each boy eat if there were 8 boys instead of 4? Right, so you know 4 boys ate 40 wings. What if we increase to 8 boys instead of 4? Now we know there will be less chicken wings per boy, and this is times 2. 4 times 2 is 8. Inversely means we would divide instead of multiply. So if you divide 40 divided by 2, you get 20. So instead of 40 wings, only 20 wings per boy. In another example, we will see how we do an inverse proportion. Super Mario runs 10 meters per second, and so he takes 10 seconds to reach 100 meters. Now, if he slows down to 5 meters per second, how many seconds would it take to reach 100 meters? Well, we know that 10 meters per second, it takes 10 seconds to reach 100 meters. If he slows down to 5 meters per second, which means divide by 2, and as we know, an inverse, we would just do the opposite, multiply. And so 10 times 2, we get 20. So he would take 20 seconds if he will slow down to 5 meters per second. And that's today's lesson on ratio, rate, and proportion. See you next time.